In this quick capture, what we're going to have a look at is what happens when we download from FTP. Currently we've got Ettercap set up to Poison 10.2 and we've got unified sniffing in progress. So you can see our two groups. We've got these connections from 10.2 onwards. So if I send a ping 192.168.10.254, okay, you can see we've got traffic here. Let's just look at the ARP cache data on this system, and again everything is going through that one connection. FTP 192.168.128.2, which just happens to be a machine in my network. Okay, we've now got a connection. We can see the connections here, and we're opening a data stream connection now, so we can actually watch what goes on backwards and forwards. Password for this system was hackme. Okay, and the password was Scooby-Doo. Okay, I'm now logged on. So I've now got profiles of all different systems and I've got a port 21 TCP connection between the two. So if I view the details of this connection, we can see the MAC addresses, the IP addresses, source port, destination port, and FTP. Okay, if we go to profiles, we can actually profile who we are talking to. Okay, remote host, it believes it's some generic form of Windows and it's at an FTP server. If we look at 10.254, we can see it's a default gateway and it's a Cisco box. If we have a look at 10.2, we find Windows 2000 Pro. Windows XP often gets confused for the two of those. Okay, if we look at 1, we find out Toshiba. That's all we know about that at the moment. And this is VMware. Okay, so we haven't really found out a great deal. If we change our visualization method and go for plain text, okay, what we're going to do is we're going to watch the traffic as we go through the network. Okay, I'm now logged on. If I type dir, the traffic that we've got here will be coming up inside these windows and forging a connection. Here we have TCP port 20, which is our data stream exchange. So this is the channel on which data will be exchanged in our network. Let's do that again. Oh, and again we've got a different network. What's happening is we're getting unique ports each time, so we're not actually gathering the information that I was hoping for. We're getting a unique port number here, 5002, talking to 20. Next time it will be 5003 when we actually ask for a command. So what we're going to do is we're going to go back to here, dir, change to 2009-09-08, which is a folder that I have a lot of pictures in. Okay, and I'm now going to set the mode to binary download, and I'm going to get 2009-09-08_99.jpg. Okay, now I've configured the server to transmit nice and slowly. Okay, and as you can see here, what we've got is the exchange of information from 2.20 to 10.2. Okay, so this is the remote host, this is the binary data, and it's been downloaded to this computer. And we're watching that traffic go as we go through. We can scroll back at any point in time and have a look at what's happening. But as you can tell, it's a raw data file formatted from as a binary file. If we just join the views, what we've got here is a hex dump of the data stream. So in effect we could actually dump that data and then do whatever we want with it at a later point in time. So what we've just done is we've used Ettercap to capture information and find out what's going on. Let's click to profiles. Okay, again, profiles here have got very little information. We know a little bit about the remote host. We know that it's Windows 2000 Pro or something like that. Again, Ettercap's got confused there because that's all it actually knows about at this time. We've got lots of other connections here. We're on port 5005 in passive mode. Okay, and here we have the control channel. The control channel is just replicating what information is going backwards and forwards. If I view that in standardized ASCII. Okay. There's nothing to see at the moment. There's no new information coming back through there. But whenever FTP sends commands through, those will come up in here in plain text, so we'll be able to see all that data. So let's just point out the obvious. Let's check the ARP cache table. Okay, this is Linux. Linux is running Ettercap, so this is going to be the master of all packets. It therefore will have all the MAC addresses correctly identified on its system. If we go to Windows, this is our first Windows prompt. If I launch a second command prompt, ARP-A, we can see that we're fully poisoned, and even though we're going from 2 to 254 out of our network to a remote host, we're still being poisoned. We're still actually intercepting traffic. We still don't know exactly where we're going, and no matter what we do here, we will still cause issue inside our capture. As you see, this stream is still active. It's counting the number of bytes. Just quickly glancing over, our FTP stream is about ready to terminate. Okay, and it has just finished. Okay, so this active session is about to drop off. It's gone into the idle state, and it will be terminated soon. So that was the end of our binary data file. Okay, well, let's unpoison, stop the ARP cache poison, okay, and stop sniffing. And if we wipe targets, okay, we're now back to a default configuration where we are not poisoning anything. Let's check what we're doing here. That's the file transfer finished. Let's have a look here at our ARP cache poison. We're back to where we should be. So very quickly, we've seen the interception of FTP traffic through a switch directly.